Okay, hello everyone. I'm Neha Kuntevar and I'll be the instructor for this problem solving sessions. And currently I'm pursuing my PhD in IIT Madras. And yeah, so we'll have this problem solving sessions every Friday from 6 to 8. So also, I mean, if you have any doubts while solving the questions and all, you can always interrupt me. Okay. So I've shared my screen with you all. Is it visible? Can someone confirm on the messages or something?
Yes, it's visible.
Okay, thanks. Okay. Okay. So yeah, so this is a course called Introduction to Automata Languages and Computation. I'm audible, right? Uh, okay. So, yeah. So this automata are basically a model that you use to, um, yeah, yeah. So this automata are basically an abstraction of the machines that we have for computation in the real world. And throughout the course, you'll be seeing different models like DFAs, then PDAs and Turing machines and so on. Even if you've not heard these terms, it's okay. I'm just saying you'll be learning the process of abstraction and how these are related to algorithms and so on. And to start with, we will start with the simplest of models that's called the finite automaton or DFA. So, if you recall, formally we've defined the DFA to be a five tuple, which is Q is the set of states, and delta sigma is your alphabet. Then you have a transition function. And then you have initial state or the start state, and then you have your set of final states. So, right. Um, okay. So, yeah, so we'll start with the first question. So these are pretty simple questions for now. So I'll read out the question for you. So you have been given a definition of a DFA, which is as we define this five tuple, and you want to tell what is wrong with the definition. So I think you can take a couple of minutes, and then you could either unmute or tell me, or you could write in the chat whatever what you feel is the correct answer. So I'll maybe wait for a minute. Okay, I see one answer in the chat. If anybody, I would encourage you all to participate if. Okay. Um, Right. So one of you thinks that B is the right answer, because the option B, which is that there is no transition function. Anybody else would has any other answer?
Option C.
Option C. Can you elaborate on that?
The Q is defined as the set of states, so the final state should be in Q.
Correct. Yeah, that is correct. So note that when once you define this Q to be some set, your initial state has to be in Q. So S is an element of Q. Whereas in this example, Q3 is not an element of Q. Similarly, F is defined to be the set of final states. So F is a subset of Q. So F could be Q0, Q1, or it could be even empty. But F cannot be an element which is outside the set Q. So in this case, we've said that Q3 is the set of final states, but Q3 is clearly not a subset of Q. So so what is wrong with the question is that, with the definition, is that your initial states and the final states are not contained in Q. Uh, yeah, and delta not being defined is, um it's just that we've not explicitly defined it, but clearly what the thing that is contradictory would be C. Is that okay? Okay, so I'll move on to the next. Okay. Okay, I'll check if there is a way to solve it. Okay, okay, so one of you says that the screen is too small, but at the moment I don't see a way to zoom it. But I hope this is manageable. Um, yes, someone has raised a hand. Can you please unmute, or maybe write in the chat, whichever is fine by you. Okay. Okay, I'll figure out. Maybe I'll figure out later offline if there's a trouble. But yeah, please, can you manage for the session? Yeah. Um, so moving on to the second question. So you've been given an alphabet, which is 0, 1, 2, and you you have to write down what is this power of alphabet sigma 1 and sigma 2. So yeah. So yeah, I mean, so this one, basically one in the superscript tells you what is the length of the strings. So since it's one, how many words can you form that? Uh, okay, I see one answer in the chat. We'll solve it and see. Okay, but yeah, thank you for answering. So since sigma 1 contains all the elements of length 1, so you can only have either 0 or 1 or 2. So this is your sigma 1, or first power of alphabet, and the size of this set is 3. Now sigma raised to 2 is the set of all elements that have of length 2. So you could have 0 0, 0 1, 0 2, or you can have 1 0, 1 1, 1 2, or you can have 2 1, sorry, 2 0, 2 1, or 2 2. So these are the only possible words that you can make whose length is 2. So sigma 2, the size of this set here is 3 square, which is 9. Okay, good. So if there are any questions that you have, please please raise your hand or write in the chat. I'm looking at the comments. Okay. So yeah, so the third question is, if it is not specified if you have not been specified anything about the alphabet sigma, then you can just assume it to be 0 1 binary every time. If nothing is specified, just assume it's 0 1. So in this case, you have been given a set S, which consists of um, okay, so I hope the idea of concatenation is fine with you. So if W1 is some string, say 0 0, and W2 is some string, say 1 1 1, then W1 concatenation with W2 would look like 0 0 1 1 1. It's just that you write the first string and append the other string after that. That's the idea of concatenation. So S is the following set, and we just saw the powering of alphabet, so you are quite familiar with the ideas of, sigma to the power 1 and sigma to the power 2. So W1 is an element of sigma 1, and W2 is an element of sigma 2, and S is defined as follows. S is the concatenation of some word in sigma 1 and some word in sigma 2, and you want to find the cardinality of S. So the question is, what is this value? So maybe I'll wait for 2 minutes or something, and um, yeah, you can write your answers in the chat box. I hope the question is clear to everyone. If not, you can, feel free to ask me. Okay. So right. So S is defined to be the concatenation of W1 and I mean the set which is concatenation of W1 and W2. Now the number of possibilities for I mean number of choices for W1 is just 2 because sigma 1 is basically 0 1, and similarly number of choices for W2 is 2 square because sigma 2 is 00011011. So since you have two choices for W1 and four choices for W2 and these are independent of each other, so number of strings you can form is 2 into 2 square, which is 8. So your size of this set S is 8 and S is nothing but sigma 3. If I mean I hope that's obvious, right? Okay, so I'll move on to the next question. Um, right, so you have been given a DFA, and now you're going to read a particular string, which is 0110101, and as you read the string on the DFA, it's going to visit the states in the machine in some order. So the question asks you to find out what is the order in which the string is going to the order of states that the string is going to visit. um, yeah, so again I'll wait for a few minutes for you to think about the problem, and yeah, then we can discuss. Okay, so I see a couple of answers in the messages, and some of you some of you think B is the answer, some of you think C is the answer. So and let's figure out. Right. So so initially you always start your transitions from the initial state, which is which you can figure out by looking at this arrow. So in this case, Q1 is the start state. So you're always going to start. I hope this pen is right. So you're always going to start with Q1, and you don't need to read an alphabet to visit the state because you're already in there. So you'll always start the transitions from Q1. Then you read 0, and that takes you to Q2. Then you read 1, and that basically takes you to Q3. Then you read a 1 again, and you go to Q6. Then you read a 0, and you stay at Q6. Then you read a 1, and you go back to Q2. And then the 0 and the subsequent 1 basically takes you to Q5 only. And one way to say this is that if you're reading a string of length size of x, then your sequence, the length of sequence is always going to be the length of string plus 1. The plus 1 accounts for the start state. So, okay, yeah, most of you answered it right, and I hope it's clear to others as well. Those of you who think C is the answer, I hope it's clear. Okay. Okay, so um, I'll just do a quick recall of what language basically is. So, a language is a subset of sigma star, and sigma star is all possible strings over sigma, and any subset of sigma star is a language. So the given question, the question asks you to identify what is the language of the automaton. Okay. I'll zoom. Okay, I see some answers in the messages. I really encourage others also to participate in the discussion. Okay. Um, Okay, so I see. I've read the answers that you have. You all have written. What I'll do is I'll explain explain the answer, and if you have any doubts after that, you can please ask. So okay, so the correct answer is A. which is W1001, W2, where W1, W2 are strings in sigma star. So what this automaton basically does is it starts in the state Q, and then it could read a set of ones. That is okay. It could read, it may not even read, but once it sees a 0, it goes on to the state Q0. Then if it sees a 0 again, then it again goes on to the new state. And once it sees a 1, it reaches the final state, and once it reaches the final state, it continues to be there. So one thing is clear, that it accepts those strings that contain uh, that contain 001. And you can also run over this and check that it does not accept any other string, meaning yeah, once you let's say read a 0 and then you read a 1, then you're again going to start in queue as if you have not even read any part of the string, and then you're again going to look for the substring 001. And if you would have, let's say, read 00 at some point and you are at state q00, then if you read a 0, then it's as good as you're going to start looking for a 001 from this place. And at this point, even after reading lots of zeros, if you finally see a 1, you will acknowledge it as if you have read a 001. And it does not matter what you read after the state q001. So yeah, and to answer the okay, I think yeah, you've got it. So if there are any doubts, please and please feel free to ask. Okay, so I'll move on to the next question. I'll maybe zoom in for you guys. Okay, so you've given this automaton and you want to identify, yeah, you want to identify what are the final states of the automaton. Right. So yeah, so I think all of you have answered it correctly. Um, Right. So as per the convention, all the states that have this double circle on it, these are the final states for us. So in this case, we have Q2, Q4, and Q5, which are this double circle things. So yeah, so these are the final states of our automaton, and it is possible that an automaton doesn't have a single final state. So in that case, F would be phi, which is which is also fine. And it is also possible that F is entirely the state Q. So in this case, the automaton. Okay, so maybe I'll ask you, if F is the set phi, then what is the language of the automaton? And if F is the set Q, then what would be the language of the automaton? And I mean, again, like since nothing is specified, you can assume sigma is binary. So I mean, if anybody of you has some thoughts, you could unmute or you could. Okay. And what about the other case? What about the other case when F is Q? Correct. So Good. So in this case, like you, some of you have answered, the language of the automaton would be empty set, and because there's no final state, it would not accept anything at all. And in this case, because everything is a final state, so every string would be accepted. Hence, in this case, the language would be sigma star. Right. Right. So now that you all are comfortable with identifying the final states and the reading the strings on the DFA, this question is going to test you to identify which string is not accepted by the automated. Right. So think okay, some of you are answering, so I'll wait for a few more minutes. Okay. So I think all of you have got this right. So the correct answer is C00. So, I mean, one way to see that would be that you run each of the strings over the automaton, and you can see whether it reaches a final state or not. So let's maybe start with 001. So if you read a 0, you go to state Q2, then you read another 0 and you go to state Q3. And now when you read 1, you reach Q4, which is the final state. So you would accept the state. Now maybe I won't go over all of them, but maybe I'll try C. So if you read a 0, you go to Q2. If you see a 0 again, you go to Q3. And Q3 is not a final state. So you would not accept the string, and hence it would not be in the language. So yeah, I think all of you got it right. I mean, if there are any questions that you have about the previous questions, or um, I mean anything related to the automaton, please, you can please ask. Okay. Right. So you've been given this automaton, and You want to identify which is the correct transition table corresponding to the automated. Okay. So yeah, most of you have answered, and yeah, I mean what you're thinking is correct. So B is the transition table corresponding to it. So yeah, so the yeah, so basically you have the set of states in the columns, and you have uh, the alphabet in the row indexed by the so yeah, so what you do is if you are in state q1 and you read a 0, then you reach q2. So this entry basically tells you that if you are in q1 and you read a 0, then you reach the state q2. Similarly, if you are in q1 and you read a 1, then you reach state q3. Now if you check between option A and B, the first entry is basically right for both. But if you look at the second entry, that is if you are at Q2 and you read 0, then you end up at state Q3, which is not, which is not the correct entry in the first table. So, I mean, if you basically verify for every state and every alphabet, then yeah, you can see that B is the one that basically corresponds to the DFA. And similarly, if you are given a table, you can come up with the DFA as well. So if if maybe like for example, if I have this table C, and I can construct the DFA using by looking at the table. So only thing that is not specified in the table is okay. Maybe I'll pose the question to you. So what is the information that is captured by the DFA, but that is missing somehow in the table?
So, I mean, in these tables, the initial and the final, I mean, no marker
Correct.
has been used to indicate the initial and the final
Correct.
states.
Correct. Good. Yeah. So as he said, you can construct the DFA, but you would not be able to identify which is the initial state and which are the final states. So yeah, good. Okay. So if there are no questions, move. I'll move on to the next question. But like I've said so many times, if there is any question, please interrupt. So, okay, is this visible, or should I zoom in more?
Yes, visible.
Okay, thanks. Okay, so okay, I mean by now, I mean, you've done enough of, processing of words. So this is probably an easy question for you. So you're given the DFA and you're given the string, and you want to tell what is the. Okay, someone says this is not a DFA. Okay, right. So, okay, 1 second, I'll modify it. Okay, so please read it like this. Thanks for pointing out. So this is not a DFA because it had two transitions on the alpha on one. So yeah, so by definition that was not a DFA, but yeah, I mean I've modified it. Please read it.
Can you please show a string? A string is not visible. I mean, with
Okay,
the string is
sorry.
right. Yeah, fine. Thanks.
Sorry. Okay. I think all of you have got it right. So um, we'll just, read the string. So you start with Q1 because that is your initial state. Then on reading 1, you go to Q4. Then you see a 0. You go to, okay, so we've read 1, 0 so far. Then you go to Q2. Then you see a 1. You, sorry. Yeah, you go to Q3, and then no matter what you see, you basically stay at Q3. So right, so Q3 is the, yeah, Q3 is the correct answer. And I'll just ask a follow-up question. So do you think the string W would be accepted by the automaton?
No, not accepted because we are unable to reach to the final state.
Correct. Okay, good. Thank you. Right. So is there some confusion? I mean, okay, sorry. Okay, so L is the language. L is the set of all strings. Or maybe W followed by 101, where W is sigma star. Okay, so yeah, I think all of you think it's a regular language, meaning there is a DFA corresponding to it. So we say that L is regular. If there exists a DFA, say M, such that the language of M is equal to L. So if you want to show that something is regular, what you would do is you would present DFA which corresponds to the language. So that is exactly what we're going to do. And I think probably you've seen a lot of such examples by now, but I mean, in this case, we're going to construct the DFA from scratch. So you start with your initial state. Then what we want is if you read the string 101, then you want to accept it, right? But what do you do if, like, in this state q0, if you say don't see a 1, then what do you do? Like, where do you want to where do you want me to draw the arrow from q0 on reading the 0? Can you, like, I mean, can one of you answer?
So a self loop would suffice.
Correct. So I'll draw a self loop to q0, which basically says that you're going to wait until you see a 1. Now let's say you are at q1, then you have already read a 1. I mean, there could be something here, some x prime, and now you have seen a 1. And okay, maybe I'll write it like this. If you are at q1, what you have read so far is a string of zeros followed by 1, and now you're looking for a 1, but now you're looking for a 0. But what if you read a 1 again? Where do you want me to draw a loop? I mean, sorry, a transition. Maybe others who have not answered it, can any one of you please answer? Okay.
So we can have a self loop over q1 for 1.
That's right. So you'll again draw a self loop over q1. Now coming to q2. Right. Now coming to q2, you have basically read a string of zeros followed by a string of ones, and I hope you're familiar with this idea of I mean, this symbol 1 plus. This is same as 1 followed by 1 star, which means you have read. Okay, so someone says okay. So we're trying to draw the trying to draw the DFA corresponding to this language. And what we've done is we've partly drawn it, meaning we've said that, okay, if it reads 101, then you end there. But the diagram is not complete because we've not drawn all the arrows. So I'm basically asking you at every point, where should I draw the arrow? So currently we are at Q2, and and there is a sorry yeah, there is a transition from q2 on reading a 1, but there is no transition on reading a 0. So I'm asking you, where should I draw the arrow?
So are you asking about the transition for 0 over the state q2?
Yes, yes.
Okay, all right. Should I answer? We can make a move to the state q0 then, as if it is the beginning of the journey again.
Correct. Yeah. Yeah, that is right. So yeah, so you make a transition to Q0 as if you've not really processed it again, and you're gonna start looking for a 1 freshly. And I think the only thing that's missing is the transitions from Q3. So if you are at Q3 and you read a 0, where do you want me to go?
So remain at q3 only, irrespective of whether we get a 0 or a 1. But I have a query here. So is this necessary that we define transition for all possible inputs over
Yes.
all the states? So is it necessary that we explore all the possibilities over all the states?
Yeah, that is an interesting question. So, by definition of DFA, when we define this transition function, right? If you remember this function from the five tuple definition, so this basically takes every possible state, every possible symbol, and has to tell you where to go. So, in the definition itself, we made it. We kind of compelled it to go somewhere. It has to it has to be complete in that sense, but later on in the course, maybe in next week or something, you will see models that do not have this compulsion. So there could be it uses some flexibility there. So for those models, maybe it's not necessary, but for the DFA that we are currently looking at, it's necessary that it has to have uh, it has to have a transition.
Because even if we do not define a transition, then by default or implicitly it could be assumed that as if we are making a transition to a dead state or sync state.
Okay,
So
so
need not to be shown explicitly. The only thing is that the system has to be deterministic, wherein we don't have options or the choices available.
okay. So if you're familiar with the idea of dead state, yeah, you can assume that there is a dead state and every other transition goes to that. But your language, um, in this case, if there were the diagram that we currently have, if there were a dead state, then the language that we are reading is not exactly the one that we want. So in order, okay,
Yes, in this case, it is not true. But I was talking in general.
yeah, sure, that is right. Okay, so Harsh says you for Q3 you go to Q0. Okay. Okay. So okay. So what happens at Q3 is that you have read a bunch of zeros, uh, and then you have read one possibly followed by other ones. Then you have read a zero, and yeah, and then you've read a 1. So basically, you've read the string 101, and now if you look at a 0, um, it's not that you did not, if you observe it from this point, you've basically read a 10 as well. So um, if you read a 1, then you are done. Sorry. I'm really sorry.
No.
Sorry,
No,
yeah.
we'll have to define transition from the state Q3 as well for 0 and 1 because this is W101 and not ending with W or anything
Yeah,
else.
sure. Yeah, right. So you've read 101, and now if you see a 0, it's as good as you've read 101 and you're looking for a 1. So the state that actually stores this fact that you've read a 10 is Q2. So okay. Right. So my claim is that if you are at Q3 and you read a 0, then you go to Q2. Is that idea okay, or maybe shall I repeat?
I think in this case, the string 10
Okay.
101 is getting accepted and which is not a valid string, which is not the part of the language.
So why is 10 accepted?
One, 10 and then followed by a 1 and then followed by a 0 and then followed by a 1. So we are reaching here after getting a 10 on the state Q2, and after getting a 10 on the state Q2, then we can repeat
Okay.
1 any number of the times. Yes,
Okay, so
it is correct. Yeah, it's right.
can you please write the string? I think I could not catch what you were saying. Can you write the string?
No, this transition is correct because once we reach to the state Q2, so we reach to the state Q2 after getting 10 as a minimal string. Starting from the initial state,
Correct.
once we get 0, we can reach to Q2, and now we can repeat 101 any number of the times,
Correct.
which makes the string the part of the language. So it is correct. Yeah. I was under a different impression. It is correct.
Okay. Yeah. Good. Anybody else who I mean is not yet convinced, and if you would like me to repeat? Maybe if you could just raise your hand, I think that would be enough. Okay. So, right. So maybe I'll just repeat it once again. So if you are at state Q3, then you have definitely read 101. And if you read a 0 again, maybe I'll use a different color. Yeah. If you read a 0 again, then it's as good as you've already read a 10 here and you're looking for a 1. So the state that captures this is Q2 because you reach Q2 when you have read 10. So this sort of captures that you have read a 10. Q2 in a sense captures that you have read a 1. And sorry. Yeah. And Q3 basically captures that you have read a 101. So if you are at Q3 and you see a 0, then you go to Q2 because it's as good as if read 10. And if that is clear, can one of you answer? If you are at Q3 and you see a 1, where should I go? Okay, others. Okay. Okay, Harsh and um, sorry, I don't know how to pronounce your name. R Goel. How
Yeah, it's okay. Goel, yeah, Goel is
Goel?
okay.
Okay. Right, Deepa, Harsh, Goel. Yeah, you're right. So if you are at Q3, then as we said, you've already read 101. Now if you see a 1, it's as good as you're only starting from 1 because the fact that you read 101 doesn't add to anything. The string that we're looking for is 101. So it starts with 1, and the state that captures this information, like we said here, is Q1. So Q1 tells you that you have read a 1. So if you see a 1, you basically go to Q1. And yeah, and the idea about uh, dead states and all, I think, I mean, we don't have any dead state here, but I mean, I hope it's clear to you all. I mean, if not, you can ask. Okay, so I think, yeah, we're done with the questions for today. But if you want me to go back to any of the questions and repeat it, or if you have any doubts, you can uh, please feel free to ask. Right. So I mean, yeah. So I think I'll wait for 2 minutes if you have any questions. But I mean, yeah. Otherwise, we're done. So I hope the session was helpful for you. Okay. Good. Thank you. Thank you. So, the recording for this will be uploaded in YouTube, and I'll share the link and all with you. And I think this PDF also, the this problem sets and the solutions that we discussed today, that also I'll be uploading it. So, yeah, I mean, thank you for attending the session, and we'll meet next Friday, same time, 6 to 8 p.m. Okay, if you don't have questions, yeah, please feel free to leave. Thank you. Um, Okay, I'll stop the recording.